Welcome, ladies and gentlemen. Thank goodness this is the last one we have to do. We're looking for the distance between two planes, so let's think about that. Again, when we talk about distance, we mean minimum distance, and again, we're going to use what's called the projection method to help us with this. There's other ways. And for this particular one, the other way won't work, I don't think, but we're going to take a stab at this one using projection. So what we need to do is we need to get a point on one plane and we need to get a point on the other plane, and we need to figure out the distance between them. And the way we're going to do that is by taking any point on one plane and any point, like these are specific points, right? These are right above and below each other. And don't make the mistake of thinking that you can just look at the z value, okay? Because even though I've drawn it this way, they could be oriented in any way, shape, or form. So what we're going to do is we're going to take the projection of, let's call it QP again. So we're going to take the projection of QP onto this red line. Now, interesting about this red line is if we were to extend it, and if we've chosen it properly so that it's perpendicular here and it's perpendicular here, guess what? It's the normal of both. Okay, so that's kind of cool. That's going to be the normal of both. Now, just thinking about that, that means that this has to have the same normal as this. Okay, so these planes are parallel. So looking at this normal is 2, -1, -2. This normal is 4, -2, -2, which you will notice that they are scalar multiples, so we can use the same normal there. Maybe I need to zoom in so that you can see that a little bit better. Maybe I've zoomed in too much now, but certainly normal 1, 2 times normal 1 is equal to normal 2, or you guys don't generally like me to write with fractions, but hey, I do things to bug you all the time, so that will be the fact that they're scalar multiples, therefore they are parallel. Therefore, planes are parallel. Now, if they weren't parallel, guys, you know that the answer to this would be 0. I know I've just blown your minds, but think about it. If the planes are not parallel, if they're not parallel like this, if one is slanted a little bit with a different, they're going to cross at some point, aren't they? Okay, so I'll do a Tanner Ryan and an Aurora here. If I use my arms and if I slant one like that, they're going to cross at some point. They have to be parallel for this answer to have any answer other than 0. They have to be parallel. So this is needed. Okay, so now using the projection method, so what you're going to look for is you're looking for the projection of QP on to N, and that's going to equal QP dot N over the magnitude of N. And again, that's going to have to be a positive quantity because it's a distance. It's going to be the distance between here and here. I could put absolute value bars around it. I'd rather not because you guys get all confused about which are absolute values and which are magnitude. So I need a point on P. So I need a point on the plane. Which plane? Let's call this one, I don't know, let's call it this one for all I care. It doesn't matter. I need a point on there. Any point will do that works. So I'm thinking 0, 3, 0. That's not always going to work, but hey, I'm going to use it as long as I can. So P is going to be 0, 3, 0, because it satisfies the equation. I need a point Q. I need a point on (4x minus 2y minus 4z minus 9 equals 0. I'm thinking this one's a little bit more interesting. Why don't I do something fun? Why don't I do 2 of these? So I'll do 2 of those, so I get 8. Why don't I do -1/2 of these? And that'll give me 8 plus 1 is 9. And then I'll put 0 in for z, and lo and behold, we'll have something cool there. Okay. Now notice your first instinct is going to be to change that to 4, -2, 0. You're going to say, well, it's a scalar multiple, it doesn't matter. And I'm going to say, yeah, that doesn't work for points, guys. Okay, if you've got a point that is, let's say, 2 comma 3, and you want to do a scalar multiple of it, of 4 comma 6, that's a different point. Okay, it's not the same as direction vectors. You're actually moving, so don't be doing that. All right, so we need to come up with QP is going to equal OP minus OQ, which is going to be 0, 3, 0, minus 2, negative 1/2, 0, which is going to be equal to negative 2, 3.5, and 0. So that's cool. What about n? Well, n can be the normal of any ones. I'm going to take the, we can use 2, negative 1, negative 2. And the magnitude of n is then going to be the square root of 4 plus 1 plus 4. So that's square root of 9, and it's only the principal square root that we're interested in, so we're going to take 3. Okay, square root of 9 is 3. And so plugging into our formula, we're going to say that QP dot n, oh, I haven't done the dot yet. Oh, no. Or did I? No, I didn't. Over top of the magnitude of n equals. So, or did I? No, I haven't done the dot. So let's do the dot. QP dot n is going to equal negative 2, 3.50 dot 2, negative 1, negative 2. And what you're supposed to do is multiply and then add. So it's going to be negative 4 minus 3.5 minus 0. So it's negative 7.5. So this is going to be negative 7.5 over top of 3. And again, we're looking at a distance. So it's only going to be 7.5 over 3. And I think I've done everything right. And if I haven't, post it in class chat. And I'm happy to come back and talk about it, but this seems to make sense to me. How about you, audience?
Yeah.
Okay.
So do we put units, 7.5?
Yeah, there's nothing wrong with that. It's our physics coming out when we do that.
And then why did you take out the negative?
Oh, because this is a distance. This is a distance.
Oh, okay.
So we can't have, so again, going back to that, a lot of times people will do this because we're only talking about the absolute value. I'm fine with that. I'm perfect with that. But just remember that that's an absolute value bar, not a magnitude bar. Okie dokie, kids. That's it. Hey, the rest is up to you. I'm moving on Monday to to Are You My Plane? That's a cute little lesson. And it won't mean much if you haven't done this work. So we'll see you on Monday. We're into our last week at that point, and keep moving. Talk to you soon. Bye.